Rules of exponents today, and there's a lot that we have to get through. I might skip some of the examples as long as we have a general idea. But when multiplying exponential expressions with the same base, add the exponents. So you might want to quickly sketch that down. If you have b to the m times b to the n, then you add them. And at the end of class the other day, we kind of went over it, right? Because this essentially is saying, if you have, right, b to the m, right, m being just a number, if it's b to the third, then you have b times b times b. If n is 4, then you have b times b times b times b, right, 4 times. And so altogether, you would have b to the 7th, so you would have to add them. And the mistake that a lot of people make is multiplying them. So, get into an example. So when we have something like this where these two things are multiplied together, remember, this is really multiplication all in here, right? This is 4 times x cubed times y to the 4th times 10 times x squared times y to the 6th. There's really multiplication all throughout there. And you can multiply in any order, right? 3 times 4 is the same thing as 4 times 3. So what I'm going to do is I'm going to look at these individually. I'm going to do 4 times 10, which is 40. Then I'm going to do x cubed times x squared, right? X cubed times x squared. And this is that other rule where if we're multiplying with the same base, we add them. So 3 plus 2 is 5, right? Because x cubed would be x times x times x. And then we have times x squared is x times x. So that's where we get the x to the 5th and why we have to add, right? Because there ends up being 5 x's. So x to the 5th. And then here to get y to the 4th times y to the 6th, we would add them and get y to the 10th. Right? So again, I'm multiplying the order I choose. I'm going to do the numbers. Then I'm going to match the I'm going to match the bases and find out their exponents from there. One more time. Again, this is all multiplied together, so I can do negative 10 times 9, which should be negative 90. And then this is x to the 1st, right? There's an invisible 1 there, so x cubed times x to the 1st is going to be x to the 4th. And then we have that y squared. And then that is all that one is. So the important idea there is if it's just x or y, there's an invisible to the 1st, it counts as 1. Okay, and then kind of going the other way, when we're dividing, right, that was multiplying with the same base. Now when we're dividing with the same base, we subtract the top and the bottom, right? And they say b can't be 0 here because you can't divide by 0. World blows up, you start World War III, something bad happens, right? And that's kind of for the same reason, right? If you have like x the 5th up top and like x to the 3rd, then what this really turns into is x times x times x times x times x, right? That's x to the 5th, x times itself 5 times, and then x times itself 3 times. And so you're going to have 3 x's in the top, cancel with 3 x's in the bottom, and you're left with x squared divided by 1, or just x squared. And so m is 5 minus 3, right? 5 minus 3 is 2. I just like to think, and instead of thinking subtraction, I always just think how many are going to cancel. That's what I like to think. So when we go to this next one, again, we can divide them all with, is someone going to ask a question? I heard a, no? Okay. So I'm just going to divide them piece by piece. 27 divided by 3 is going to be left with a 9 on the top. So 9. X to the 14th divided by x to the 3rd. So 3 x's are going to cancel with 3 x's here, which is going to leave me with 11 of them up top. So 9x to the 11th. And this is actually going to all end up in the top. So I'm just going to write 9x to the 11th. And then 5 y's in the bottom here are going to cancel with 5 of the y's there. and leave me with 3, right? If I have 8 y's and 5 of them cancel, I'm going to be left with 3 of them. And then technically, all this is canceled, right? And what's left in the bottom is not 0 or nothing, but 1, right? And something divided by 1 is just itself. And that'll be important if we have to simplify the top down. Again, we're just canceling what we can here. We have 5 and 125. Now, that goes to 25, but it's going to be 25 in the bottom, right? So 25 in the bottom. Right. And then because if you do 125 is 5 times 25, so the 5's cancel. Now 5 of the x's here cancel with 5 of the x's there, and I'm just going to be left with a single x. And then 3 of the y's here cancel with 3 of the y's there, and I'm going to be left with 3 y's, or y to the third. Why did I put the x and the y cubed? Because there's more x's in the x and y's in the top than in the bottom, right? So here, 125 is bigger than 5, so what's left over is going to be in the bottom. But here, there's more x's on top. So if I were to write out x to the 6th, that would be x times x times x 6 times, right? And if I were to write out x to the 5th, that'd be x times x times x 5 times. So 5 of these x's in the bottom are going to cancel with 5 of the x's in the top. And after I cancel them with 5 of the x's in the top, since there's 6 of them, there's only going to be 1 left, but in the top, right? So if it was switched and x to the 6th was on the bottom and x to the 5th was on the top, then the x would be down here, because then, right, if this was 6 and this was 5, then 5 of the x's there would cancel with 5 of the x's here, but there would be 1 left in the bottom. Is that helpful? And I think that'll also help maybe with this one. This is one that people always forget what it means. If you have a negative, this honestly is just right. Here's what I'm going to say. I would maybe write this down because everyone's confused about negative exponents. If you have a negative exponent, all it means is throw it to the other side of the fraction and make that exponent positive, right? So when we have something to the negative whatever, right, that's the same thing as over 1, right? So now we're just throwing it in the bottom and making it positive, right? And then there's still a 1 left up top, right? You can't just have nothing up top, right? That 1 needs to stay there. And same logic backwards, right? If you have a negative exponent in the bottom of a fraction, you just move it to the top and make it positive. So negative exponent means move it, right? If it's a negative exponent in the bottom, move it to the top, make it positive. If it's a negative exponent in the top, move it to the bottom and make it positive, right? That's all a negative exponent means, is move it and make it positive. Like this. Move the negative 1 to the bottom, make it positive. Keep the positive 1 where it's at. Or if they happen to be the same, right? If we had x to the third times x to the negative 5th, then that's x to the third over x to the 5th. 3 x's cancel with 3 x's here, and you're left with 2 x's in the bottom, right? If you take away 3 from 5. And that also does our, right, if we, same base, multiplying them means add would be x to the negative 2. That was our first rule, which is 1 over x squared, so it works multiple ways. negative children go to the basement. It's funny, Mr. Kirschman talked about his grumpy old grandpa that he would throw in the basement. That's how I learned. Is Mr. Kirschman next door to me when he had me? He said his grandpa was essentially just a pain at like holiday events, and when they'd get pissed off at him, they would just throw him in the basement. So you'd say, "Throw grumpy old grandpa in the basement," right? So throw the negative exponent in the bottom, make it positive, because then everyone's happy that grumpy old grandpa's in the basement or something. Um, I like that, as long as you also know that you could take them from the basement and put them upstairs too, right? As long as it goes both ways. So for these ones, just be careful. Just be careful what the exponent is actually hitting. So this just wants us to rewrite this with all positive exponents. So 4 times x to the negative 3. The x is the only thing with the exponent, so I'm going to put that in the bottom and make it negative. Throw grumpy old grandpa or the negative children or whatever in the basement, right? Make it positive. So, and then here, it's the entire quantity 4x, so we're going to do 1 over, and then it's the entire quantity 4x cubed. You know what I'm going to see a lot of? I'm going to see a lot of just moving the x to the bottom, or I'm going to see a ton of this. This is bad. No, it's the whole thing, right? It's in parentheses, it's the whole thing. So keep it the whole thing. This one, same idea. It's the whole thing, but moved to the top. So it'd be 4x altogether cubed, right? Not 4x cubed. This one, however, would be, you move, this one's a little weird. The 4 doesn't have a negative exponent, so that stays in the bottom, but the x cubed gets moved to the top. 1 times x cubed is just going to be x cubed, and then you leave the 4 in the bottom. Right? That 4 stays there because that 4 doesn't have a negative exponent on it. So you just really have to be careful with what you're doing there. Okay. So use the negative exponent rule to write 5 to the negative 2 with a positive exponent. This always kills people, right? Because we know what 5 squared is, but once you put a negative exponent, even after we just go over it, people are like, wait, what? Just remember what it means. That means throw it in the basement, right? So we have 5 to the negative 2. That's the same thing as 1 over 5 squared. And we know 1 over 5 squared is 25. Right? So 5 to the negative 2 is actually 1/25. And so now use the negative exponent rule to write this with positive exponents only. And so this 3 stays up top. This x to the negative 6, that's going to go to the bottom, make it positive. And this y to the 4th stays on top because it's positive. So if it's negative, just move it. If it doesn't have a negative exponent, you better leave it. Any questions so far? I know I'm kind of lightning rounding this. But all right, so now using everything that we've learned, I'm going to do 4 and 20 first. Right, 20 is the same thing. A lot of us can do this in our heads, but if it helps, 20 is the same thing as 4 times 5. Right, so the 4s are going to cancel, and a 5 is going to be left in the bottom. Right, and now we have x to the 5th and x. One x is going to cancel with one of the x's here, so there's going to be 4 of them left in the top, right? If you have 5 in the top, 1 in the bottom, they cancel. 4 are going to be left up here. Now we have 1y, and that's going to cancel with one of the y's down here, and we're going to be left with y to the 7th down there. So maybe just to write it nicely, x to the 4th over 5y to the 7th. Okay. Here, again, 125 and 20, it might be easier to split it up if you can. 125 is the same thing as 25 times 5, right? 20 is the same thing as 5 times 4. The 5's cancel. 25 and 4, I don't think anything goes in there, right? The only thing that'll really go into 4 is 2. 25 obviously is indivisible by 4 or 2. So we're going to leave it as a 25 on the top. We really just reduced the fraction, right? That's all we're doing with those. 2 x's in the top, 8 x's in the bottom. 2 x's are going to cancel with 2 x's there. So in the bottom, we're going to be left with 6 x's. And then 5 y's in the bottom are going to cancel with 5 y's in the top and leave 2. So y squared. And so we're left with 25 y squared all over x to the 6th. Okay. And then this should be the last one, the power rule. When we have exponents to exponents, that's when you multiply them. So the big mistake is, right, if we have x squared times x cubed, a lot of people are going to multiply that to x to the 6th, but that's wrong, right? You add these, right? There's 2 x's and 3 x's. You add them all together is going to be 5. But when we have exponents to exponents is when we actually multiply, right? So if we have x to the 2nd to the 3rd, that's when we multiply them to be to the 6th. And I remember being in high school, and it was almost like I remember learning these, and I was just thinking, man, how am I going to remember? Like, I get it, like, right? You get it now, but like 4 months down the line, how am I like? How do I remember that on top of remembering everything else I have to remember for math? And one thing, one way to is to just it better make sense, right? Think of what x squared and what x cubed means, right? This means x times x, and this means, and x cubed means x times x times x, right? So altogether, that's going to be x to the 5th, right? So if you need to think about it logically like that, that's fine. What does x squared to the 3rd mean? Well, to the 3rd means something times itself 3 times. So take x squared and times itself 3 times, right? And now we're down to this, where we add 2 plus 2 plus 2 is 6. That's one way. Another way I like to think about it is we know our order of operations, PEMDAS, right? When we're working with exponents, I don't know if this doesn't make sense to you, just ignore it. But this is kind of how I thought about it when I was in high school. So we have a power to power, right? Power goes first. We're kind of always working a step down in PEMDAS when we're dealing with exponents. So if we have a power, we multiply them. But if we're multiplying them, we're adding them. You see how we kind of like step down if we have a power, or multiply them. But if we're multiplying them, we add them. Multiplying them, we add. Power, we multiply 2 times 3. So if that's helpful, you let it be what it is, right? So for examples here, simplify the expression using the power rule. X to the 3rd to the 7th is going to be, you just multiply them, x to the 21st, right? 3 times 7. And again, if you need to make sense of it, x to the 3rd to the 7th, that means x to the 3rd 7 times, right? So if I do this 7 times, I should get 21 x's all laid out. And I just realized we haven't, I think we actually have 2 more rules to go over, and we can't do this one yet, but that's okay, because we'll cover it in another one. Yep, this is the next rule. And so, this is the thing that everyone likes and wants to do. If you have things multiplied all together to a power, you can pretty much just distribute that power to both, right? Because, for example, if you had AB squared, that means AB times AB, right? And you can multiply in any order, so you do the A squared and then the B times B is the B squared. So this is the case where you can throw that into both if they're being multiplied, right? We have the big algebra no-no, right? Everyone wants to do this, but this is bad, right? You have this rule, but don't let that think you can do this, right? You can't distribute unless it's multiplying. If there's addition or subtraction, you're screwed. You can't do it, right? Because x plus y squared means x plus y times x plus y, and then you have to FOIL and do all of that. Right? Okay. So, simplify. We just stick both. We pretty much just stick the exponents in this. So we have negative 4 to the third times x to the third. What is that? Negative 64 x to the third. And if you're having trouble, like, is that negative included or not, this is where thinking about it can be helpful, like logically, right? Something to the third really means negative 4x times itself 3 times, right? So negative, negative, negative is going to be a negative in the end. 4 times 4 times 4, 64, x times x times x, x cubed. Right? But what I really did is I just distributed that cubed into both. So now this cube goes into both, so we're going to get negative 2 cubed times x to the fourth cubed times y squared cubed. And now here's where we have to be really careful, right? Negative 2 cubed is going to be negative 8. X to the fourth to the third is going to be x to the 12th. Y squared to the third is going to be y to the 6th. We're multiplying, right? Powers to powers, you multiply. And instead of, writing all this out, hopefully eventually we can get comfortable with, okay, negative 2 cubed is negative 8. X to the fourth cubed is 12. Y squared cubed is to the 6th, right? And again, if it helps, I'm not going to write all this out, but you can imagine taking this whole thing and multiplying it by itself 3 times. You should get 4x's, 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 12, right? 2y's, 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 6, right? Negative 2 times negative 2 times negative 2, negative 8.